A doodad stands on the central axis of a mirror. For each situation, determine the missing pieces of information. From the magnification value, determine the image characteristics and draw a ray diagram. So since we have 3 situations, I'm gonna, for each of the mirrors, I'm just gonna do one at a time. So the first thing that we got to do is that we have to determine what type of mirror we're talking about. I'm saying that this is a converging mirror. And the question is, why do I say this is a converging mirror? The image location S prime 1, which is 36 centimeters, is positive. So that implies that it's, so if the image is positive, then it forms a real image. This can only be produced by a converging mirror. Or if you want to say concave mirror, that's okay. So what I'm going to do here is that note I have to calculate the object location, and I also have to calculate the focal location. So using the magnification equation, the object distance S1 is M1 minus S1 prime, S1. Now I'm going to isolate S1. And when I do that, I get minus S1 prime divided by M1. So just plugging in the values from the table, I'm going to get minus 36 centimeters divided by minus 2, which then gives me positive 18 centimeters for S1. So I now know the object distance. So now what's going to happen is that I need to calculate the focal length. So I'm now going to use the mirror equation to calculate F1. So then that tells me here is that this is F1 has to be the inverses of the object plus the inverse of the image, which then if I mathematically solve, I get F1, and it's going to be S1 plus S1 prime, S1 times S1 prime. Putting in my numbers, you could see that S1 is 18, and then here that's 18. So then the image is 36. So if I compute this number, I get 12 centimeters for the focal length. So now I have all of the information that I need. So now from the magnification equation, so I'm going to say that the magnification equation, how about the magnification and image characteristics are as follows. So note that they tell us that m is already minus 2, but we should always calculate it So it should be minus S1 prime, S1. So if I plug that in, note that the object is 18 centimeters. The image is 36. So you could see here that I get -2 for the magnification of 1. Again, this is given, but I'm calculating it this way. And so now from this, I want to get the characteristics. So let's look at that. So I see here that I have a minus sign. So the minus sign tells me two things. It tells me that the image is inverted and real. Now the magnitude of the magnification is 2. That tells me that the image is larger. So now what I'm going to do here is that I'm going to sketch in my ray diagram for my mirror. So here's my ray diagram. And what's going to happen here is it goes like this. So I'm going to paste this guy in here. And then I'm going to try to look at this here. So what you're seeing here is that I'm going to set each square for a scale of 5 centimeters is 1 square. So you can see that F1 is about the middle. F2 is going to give me about, that value right there. You know what? It should actually be should be more right here. So now what I want to do here is that I now need to identify where my object starts at now. So my object is at 18 centimeters. Okay. So if it's at 18 centimeters, I'm going to say that my object is going to be about right there. So here I go. So my object, I'm going to say is, let's say it's 1 square. And so what this is telling me here is that the distance from here to here, this is S1. So here we go. So the first ray does what? I have a ray that goes parallel to the axis. This is ray 1. And then what it does here is it reflects through the focal point. So if I draw this, it's going to look something like this. So there is my ray number 1. My second ray, what I'm going to do here is that I'm going to pick the inverted point, and it goes like this. So it goes to the middle of the mirror, right? It goes to the middle of the mirror. And then, that's not the middle of the mirror. How about a little bit lower? And then it reflects to that point. Okay, and it reflects through that point. And where those rays cross tells us where the image is at. So it looks like it crosses about right here. So then this guy, this tells me the distance S1 prime. So that looks about right here. So according to this here, look what happens. The magnification is not exactly 2, but I would say that the magnification is about 1.8. So I'm going to say that's pretty close to 2. And the other thing here is that look at the distance. So it goes 1, 2, 3, 4, 5, 6 squares. So this tells me that S1 prime is about 6 times 5, which will then be 30 centimeters. Well, you could see that the actual distance is more like 36. That's why we rely on the calculations. Okay, so the next thing we want to do is that we want to go in and we want to look at mirror number 2. So pasting this in, let's do mirror number 2. Now, what do I know about this guy here? If I look at the magnification, note that the magnification is positive and larger than 1. So we know it's an erect image, but it's larger. So what this does here is that this is a converging mirror. And again, the question is why? I have a positive magnification that is larger than 1. Diverging mirrors produce positive magnifications that are less than 1, while converging mirrors produce larger than 1. So this immediately tells me that that this is a converging lens, so therefore the focal length here, we know the length of the focal length, which is 18, we now know that it has a positive sign. So now we know the type of mirror and we know the sign of the focal length. So now what I'm going to do here is that you can see here is that I don't know S and I don't know S prime. So to calculate both S2 and S2 prime, we set up two equations and two unknowns. So the first one has to be the mirror equation. So when I look at that mirror equation, it says 1 over S2 equals 1 over S2 plus 1 over S2 prime. And I also have a second equation in the magnification equation. And the magnification equation says that this is minus 2 prime over S2 is equal to positive 2. So now what I'm going to do here is that the easiest thing that I could see here is that I'm going to solve for 1 over S2 in equation 2 and substitute it into equation 1. And now we can solve for S2 prime. So let's do that. So the first thing you see here is that I have 1 over F2. And then what you're going to see here is that I have 1 over S2 plus 1 over S2 prime. Now look at the magnification equation. If I bring over the S prime 2 to the right side, I then can replace this with minus S2 prime divided into 2 plus 1 over S2 prime. And what you're going to see here is that then this immediately gives me minus 1 over S2 prime. So that means I can now solve for S2 prime, which is then going to be really minus F2, but we know F2 is 18, so therefore this must be a negative 18 centimeters for S2 prime. So now I know my image location. So from the image location, what I'm going to do now is I'm going to now sub S2 prime into equation 2 to get the object distance S2. So if I do that, note that I could immediately write that this guy's going to be what? It's going to be S2, it's going to be minus 1/2 S2 prime. So this will be minus 1/2, and of course this is minus 18 centimeters. So I get positive 9 centimeters for my object location. So now that I have that, I want the magnification to get the image characteristics. So the magnification and image characteristics are as follows. So I got M2 minus S2 prime over S2. So this will then be minus 18 divided by positive 9. That gives me positive 2. Again, we knew that already. That was already given. So this guy is M2. So from this M2, I'm going to get the characteristics of the image. So what do I see here? Well, for starters here, I see a plus sign. A plus sign says that the image is erect, and because it's erect, all erect images are virtual. And then the other characteristic here is that I see that M2 is 2, so that means that the image should be 2 times larger. So the image is larger. So now that I got all the characteristics, what I'm going to be doing now is that I'm going to calculate I'm going to draw the ray diagram. So let's look at that. So here's my ray diagram. So I'm going to punch this guy in. So I've already set up a couple of things. And let's see if I can do that right there. So what you're seeing here is that I set each square to 9 centimeters. And the reason why is the focal length is 18. So what I'm seeing here is that this is F1. Now remember, again, the light is coming in this direction. My object is located at 9, so that means here, I'm going to draw it right here. So this tells me that this distance from here to here is now S2. And note that I called that F1, it should be F2. Now let's draw my ray diagrams. So my central ray diagram goes like this. So I go parallel to the axis, and then it has to go through the focal point. Now, because the object is inside, I now follow the rays backwards. So my ray goes like this, and then it goes out that way. Now what I want to do here is that I need to find the opposite of that image, and then I'm going to draw my diagram here. So now let's go do that. So then this guy goes to the middle, right? It goes to the middle of the lens, of the mirror, and then it reflects using the law of reflection. So it has to have the exact same angle. So then I now follow it back. And so you could see that here's my ray number 2. So where is my image here? So my image here is going to be about right here. So that means here is that this distance from here to here is S2 prime. In other words, that image is behind the mirror. So now let's go look at the location S prime. So what's the length that I calculated here? So if each square is 9 centimeters, then I got 1, 2. So that's 18. I'm going to say somewhere around what, 25? Wow, that's really yeah, I'm going to say that's probably not, yeah, let's say 25, 24 centimeters. And then the magnification, what is that looking like? Well, it looks like it's more than double. So I'm going to say that's about 2.5. Well, looks like our graph didn't do so hot. But that's why we rely on our calculations here. So let's go look at this guy here. Mirror number 3. So mirror number 3. What do I see for mirror number 3? Well, if I look at the magnification again, like we did last time, we know that it has to be a diverging mirror. So this is a diverging mirror. And of course, the question is why? The magnification is less than 1. Okay? If the magnification is less than 1, this can only be produced by a diverging mirror. Now I realize this is, I'm going to say that this is not negative, so I should say that this is a positive magnification less than 1. So that means that the image has to be erect and smaller. Only a diverging mirror can do that. So therefore, when I look at the focal length, it has to be negative. It has to be a diverging mirror. So now I know the mirror and I know the focal length. So all I have to do is calculate the image distance. So then I'm going to use the mirror equation to calculate S prime 3. So then I'm going to have 1 over F3, 1 over S3, 1 over S3 prime. I'm going to isolate S3 prime. So this will be S3 minus F3, S3 times F3. Now I'm just going to punch in my numbers. So if I look at my numbers, my object is 8. And I'm going to have minus 10 for the focal. So then this will be 8 times minus 10. And then I get a value of minus 4.4 centimeters for the distance S3 prime. So now I have my image distance. So then the last thing I got to do here is that I look for the characteristics. So the magnification and image characteristics are as follows. So M3 will be minus S3 prime over S3. So then I'm going to get minus 4.4 divided by 8, and I'm going to get a positive 0.56 for the magnification 3. So we now have our magnification. From our magnification, we're going to look at the characteristics. So the characteristics tells us that we have a plus sign, and that plus sign tells us what? That the image is erect and real. Ooh, not real. That's virtual. And the fact that its magnitude is 0.56, that tells us that the image is smaller. So now what's left here is that we need the ray diagram. So I'm going to use what I already have drawn before. And this is a diverging mirror. And here we go. So what do I know? I know that the focal length is 10. Okay. So this is really, what do I mean by this guy right here? This is the focal length right here. So this is minus 10 centimeters. How about if I just do it like this? I'm going to go from here to here. This is F2 of minus 10 centimeters. Now remember, the light is still coming in from the left. So where is the object? The object is located at 8 centimeters. So let's be careful on how I set my scale. So if my focal length is 8, I'm going to say that each 2 squares is going to be my focal length right here. So where is the object located? Well, the object is located at 4.4. Okay. So if it's at it's located at 8. The focal length is 10. So I'm having trouble here. So every 5 squares, every square is, so let me set my scale. Every square is 5 centimeters. That's 1 square. So that means here that my image has to be inside the first tick. So I know that this guy right here is F. So now my object is at 8. So I'm going to draw this, let's say this high right here. I'm going to say that this guy is my object here. So now let's draw my rays. So the first ray goes parallel to the axis, and then it diverges when it hits the mirror. So then that means it goes here. Now I'm going to follow this guy back. So there's ray number 1. The second ray reflects. So it looks like that's 2 squares. So it's got to reflect to right there. So if I look at this, then the reflection looks something like this. So it goes from here to here. And then it goes from there to here. So what I'm going to do here is it looks something like this. So I go from here to here, and then I follow it backwards. So now where these rays cross is where my image is going to be located. And this image, so if that's 5, it looks like I'm getting from here to here. This is going to be S3 prime. And you could see here is that now our S3 prime looks like it's about -4 centimeters. And then the magnification 3, well, it looks like it's about 50%. So it looks like these guys matched up pretty well.